All right, welcome back to Mr. Womack Help video number 2. Hopefully you've made it through the first 7 questions without crying and tears, and it was pretty okay. Now you've read question 8 and you're scratching your head and going, why on earth did I take Mr. Womack's aerospace engineering class? Or you're like, this is way cool, and you're doing great. If you're one of those, you might not even be watching the video. However, if you're here, then you're stuck. So we're going to look through this, and I'm going to help you walk through, and we're going to talk about the 4 steps down here so that I can help you. All right? So we have this Boeing 777, and it's loaded to 92% of its maximum takeoff weight. This is an important piece of information. Okay? And we also need to know its maximum weight right here at takeoff. So it's going to take off at Dubai at an airport, international airport, during an average day in July, and they give us our temperature, so we're going to need that temperature too, with a standard pressure, and this is our standard pressure, which really doesn't change. And we're going to assume the takeoff speed is 376 kilometers per hour. Again, information I'm going to need. What is the minimum coefficients? We're going to be finding the coefficient of lift needed at the point where the aircraft just lifts off the ground. So we're trying to find out how much lift is needed for that airplane to get its wheels just off the ground. Okay? So they give us that. They tell us our maximum takeoff weight is right here. So this is a really key piece of information. And its wing area is this. So here's some info that we need. Now, the first thing we need to do, if you looked right here, I gave you step, is we need to convert mass into weight. If you remember from our slides before this, or the presentation before it when we were introducing this, that we have to convert mass to weight. Why? Because what is trying to pull that plane out of the sky all the time? Gravity. Mass and weight are not the same thing. Weight is the effect of gravity on mass. So we have to calculate gravity in there. All right? So first we need to go back up here, and we know something about our plane. It's only loaded to 92% of its maximum weight. Well, this is its maximum weight. So we need to take 92% of this and convert it to weight. So here we go. How do I do that? So in question 8, where is my, oh, here's my stuff. Okay. So to do that, sorry, Mr. Womack lost his spot here. Right? So we need 92%. So we're going to have 92%, which is actually 0.92, times the mass, because we're taking 92% of our mass, times our gravity. Okay? So this is how we're going to do this. So we have 92, and then our maximum weight is 347,452 kilograms. Is that correct? So we have that, and then we're going to multiply that by gravity. Well, they really didn't give us the value for gravity, and that's not in here, but if you've taken physics, you will know that gravity is the force of gravity on an object is making it accelerate at 9.81 meters per second. That means if I've got something, when I let go of this pin and it falls, that means gravity was pulling on it and that pin was falling at 9.81 meters per second. Okay? So that's what that means. All right? So there's my problem. I calculate that out. So there is step 1. So take a moment, do that please, calculate that out. I'm not going to give you that answer, okay? So you get to work that. Step 2 is to convert kilometers per hour to meters per second. So we go up here, step 2, I need kilometers per hour and convert it to meters per second. All right, so remember when we did that, we are going at 376 kilometers per hour. So I have to convert kilometers to meters. So there are 1,000 meters per kilometer. Okay? Right? And then that's the kilometers. Now we have to convert hours into seconds. So there's 60 minutes in an hour, but there is 60 seconds in a minute. So we have to do that, all right? So we cross out, those cancel out, minutes cancel out, okay? Our hours cancel out, so that leaves us with meters per second. So you're going to do 376 times 1,000 and divide that by 60 times 60, and that's going to give you your answer in meters per second. Okay? That is step 2. Step 3. We need to calculate the density of our air. So density. So we need our formula for density. All right. So here's what we know. Our formula for density. I'm going to try and do my crazy little P right there. So formula for density is pressure over our constant, which is 0.2869. Okay. And that's going to be times our temperature plus our constant for Kelvin, which is 273.1. Okay. And that's what we have right there. Okay. So let's look back at our problem and see what we have. They tell us our pressure of that day is standard air pressure, so it's 101.3. So you plug that in, 101.3 over, this is a constant, 2.869. So that's cool. They tell us our temperature that day is 34.5 degrees Celsius plus 273.1. Okay? You calculate that all out, and that's going to give you your air density. Okay? So that will give you your answer. Again, I am not going to solve it for you. You have a calculator. I've set it up. You should be able to plug in the numbers. All right? Now, step 4 is we're ready to actually calculate the air density. Now, I'm not going to put in some values because you're supposed to solve those up there. So here we go. Good luck. And here's our coefficient of lift formula that we have. So coefficient of lift equals 2L over the area of our airfoil, our air density, times our velocity squared. Okay? Oops, I put a big old thing out here. All right? So, 2. What is L? L is your answer from step 1. Okay? So, step 1 answer. So plug in your step 1 answer right there. Okay, area was given to us right here in our problem. So area of the wing is 427.8 square meters. So I'm going to put 427.8. Make sure I copied that down right. Yes, 0.8 meters squared. This doesn't mean the whole thing is squared, just the little meters there. Okay, times our air density. This is step 3 answer. Okay, and then the last one is velocity squared, which is going to be step 2 answer. And you're going to square that one. All right, so remember order of operations. You should end up squaring this first, then you'll multiply this out, have your answer, multiply that out, divide the top by the bottom answer, and that's going to give you your coefficient of lift. You should end up with some sort of small number, okay? So hopefully that you have done that particular part, and there you go. Okay? So there is problem number 8. Good luck.